Hello, welcome back to my YouTube channel, and thank you for tuning in. So today I'm bringing you chemistry, and it's about the pH scale. I want to discuss with you what is the pH scale, what does it consist, and how does it work. So you might be wondering, what is the pH scale that I am referring to, and how does it work, and what does it do? So a pH scale, it is just a scale that is used to specify the acidity or the basicity of a solution. So if I have a solution and I want to know whether it is acidic in nature or it is basic in nature, I will automatically use the pH scale to determine the acidity in it or the basic nature in it. So the pH scale ranges from 0, as you can see, 0 to 14. It ranges from 0 to 14. It has these values from number 0, 1, 2, 3 up to 14. And we also have acids and basics inside the pH scale. We also have a neutral solution in the pH scale. So number 7 here, it's always neutral. It's neither acidic nor basic. It's neutral. I can say it is in the middle. It's neutral. It's neither acidic nor basic in nature. And the values below 7, that is from 6 down below to 0, these values here, they are acids. 0 to 6, they are acid. And the values above 7, now here from 7, 8, 9, 10, 11, 12, 13, these values here are basic in nature. So 7 is neutral. Below 7, the values below 7, acidic. The values above 7, bases. They're basic in nature. So I want to take you through these acids from 0 to 6. We have strong acids and we also have weak acids. So from 0 to 3, these values that range 0 to 3, the values that are within, this is now 1, 2, and 3, are strong acid. So if you have a solution and it has a pH value of 2, it is a strong acid. If it has a pH value of 1, it is a strong base. On the other side, if it has a pH value of 4, 5, 6, it is a weak acid. So I want to take you through what is this strong acid and what is this weak acid, or what is this that distinguished strong acid from weak acids. So let me take you through strong acids. So a strong acid is an acid that completely dissociates in aqueous solution. So it completely dissociates. What is this dissociation here? To dissociate means that it splits into smaller atoms, or it splits into small ions. This is now the strong acid. So if a strong acid, it completely until that solution becomes clear, this means that it completely dissociates in a solution, whether it's water or anything or any other solution, it dissociates completely. This means these values from 0 to 3, they are strong acids because they dissociate completely. They split into smaller ions or smaller atoms in a solution, in an aqueous solution. So we have examples of these strong acids, which include hydrochloric acid. We also have nitric acid. We can also have sulfuric acid. These are examples of strong acids. Let us now and remember, strong acids have the value of 0 to 3. These are now the strong acids. Let us now look at weak acids. These weak acids, they range from 4 to 6. This means if you have a solution and it has a pH value of 4, 5, or 6, it means it's a weak acid. Now, weak acids on the other sides are acids that do not completely dissociate into their constituent ions when dissolved in a solution. So if we dissolve a weak acid, it will partially dissociate, or it will not completely dissociate. It won't split into these smaller ions completely. It will just partially dissociate, and that's it. So these are weak acids, and we have examples of weak acids. There are so many, but I can give you just an example here. I have lemon juice and ethanoic juice. So they might have a value of 4, 5 or 6 because they are weak acids. They do not completely dissolve in a solution, and therefore they are weak acids. The next, now we have this 7 here, the pH 7. It is a neutral, and an example is water. We drink water, we all drink water, and water, it's neutral. It's not acidic nor it's basic, and that's why it's advisable for us to drink water, because it has no harm. It doesn't have any harm because of its nature. It's neutral. It has a neutral pH of 7. So on the other side, we have on this pH scale here, we have the values that are above 7. This is 8, 9, 10, 11, 12, 13, and 14. As I've earlier said, they are basic in nature. We also have weak bases and strong bases. Weak bases range from 8 to 10. So the values that are in between, this is 8, 9, and 10 are weak bases. So if you have a solution and it has a pH value of 9, no, it's a weak base. And weak base or weak bases do not partially dissociate. They also do not partially dissociate into their constituent ions when dissolved in a solution. So if we dissolve something like, or a solution like ammonia, it won't completely, though the ions inside there won't dissociate completely. They won't split or break down completely. They will break down, or they will dissociate partially. But for the strong bases, these are bases which completely dissociate into or in its ions when in water or when in any other solution. And there are examples here. We have sodium hydroxide. It's also a strong base. We also have other strong bases like the solution of wood ash, sodium hydroxide. These are bases in nature, and they have a pH value above 7. So we have gone through weak bases, strong bases. We have gone through strong acids and weak acid. For both strong acids and strong bases, they completely dissociate in a solution. But for both weak acids and weak bases, they partially, or they do not completely dissolve in a solution. So that is the only difference between strong and weak bases, or strong and weak acids. And this is the work, or this is what the pH scale does. It specifies the acidity or the basicity in a solution. So the values range from 0 to 14. So if we have 7, it's neutral. Above 7, it's basic in nature. Below 7, it's acidic in nature. So that is it, and that marks the end of our video today. Remember to like, subscribe down below, comment down below, and bye. Let's meet in our next video. Bye.